we have defined fraction as the quotient of two integers. The denominator integer has to be non-zero. So today we are going to talk about how do we operate fractions. How do we plus, minus, multiply, and divide with the fractions. So firstly, let's look at the two properties for fraction. The first property is called multiplication property of fractions. Multiplication property of fractions. It says if we have a fraction, let's say the fraction is a over b. Here b has to be non-zero. Then if we multiply both top and bottom, both numerator and denominator of this fraction by a non-zero number c, see the numerator a multiplied by c over denominator b multiplied by c, then we will have an equivalent fraction. So the value will not be changed. The value of the fraction will not be changed. So that means if we have a fraction, if we need, we can multiply both top and the bottom by the same non-zero quantity. So that's the first property for fractions, multiplication property. The second property is called division property. Division property of fractions. It says if we have a fraction a over b, if we divide both top and the bottom by a non-zero quantity, then we will have an equivalent fraction. The value of the fraction will not be changed. So it means if we need it, we can divide both top and the bottom of a fraction by a non-zero quantity without changing the value of the fraction. So those are the two important properties for fractions. Is that clear? Yeah. It tells us what we can do for fractions. Yeah, we could multiply both top and the bottom of the fraction by a non-zero quantity if we need it. Or we could divide both top and the bottom of the fraction by the same non-zero quantity c without changing the value of the fraction. All right. So we need those two properties for the operations with the fractions. So the first example, let's see how do we simplify a fraction. Simplify a fraction is also called reduce a fraction. I have the definition right here. You can copy it down. Reducing a fraction is to write the fraction in the lowest form. Write the fraction in the lowest form means you're going to write the fraction in a form in which the top and the bottom of the fraction are mutually prime. Do you guys still remember the concept of mutually prime? Mutually prime. Two numbers are mutually prime if the only common factor of them is 1, right? Two numbers are mutually prime if the two numbers only has one common factor, which is 1. So they do not have any common prime factors. In that case, we say the two numbers are mutually prime. If you have a fraction, numerator and denominator are mutually prime, then the fraction is simplified, is reduced, is the lowest form. Then the fraction is in the lowest form. Am I clear about the definition? Yeah. So reducing a fraction is if we have a fraction, we need to rewrite the fraction as its equivalent fraction in which numerator and denominator are mutually prime. So let's see the first example. Reduce 30 over 36. I'm going to write a solution here. We're going to reduce this fraction 30 over 36. This is a fraction. Numerator is 30, denominator is 36. Anyone can tell me if you look at the top and the bottom, anyone can see if this fraction reduced or not. It's not, right? Yeah, because obviously the numerator and the denominator are not mutually prime. They have a common factor, right? Yeah, very obviously, numerator is an even number, denominator is an even number, right? So they are not reduced. So this fraction is not reduced. To reduce a fraction, we have I'm going to give you two different methods. The first method, or the first solution, is firstly, I look for the GCF. We learned GCF earlier, right? GCF of the numerator and the denominator. Okay, I'm going to give you 1 minute to see if you can find the GCF, the greatest common factor for the numerator and the denominator. We have a 3-step procedure, right? When you look at the two numbers, you know this is not the first special case. It's not the special case number 2 either. So you want to apply, you have to apply the 3-step procedure. Like a prime factor 30. Do you guys remember that? Prime factor 36, right? And then you line up the two factorization vertically. And then you read a bubble common factor, right? That's the step. Step 3 is to multiply the bubble the common factor. Okay, you guys tell me what's the GCF of 30 and 36? 6. Very good. Okay, very good. So once we found the GCF for the two numbers, the numerator and the denominator, we can simplify this fraction by applying the division property of the fractions. So we're going to divide both top and bottom. We're going to divide the top by the GCF, divide the bottom by the GCF. And then let's see. We know this operation, like dividing both top and bottom by non-zero number, will not change the value of the fraction, right? Yeah, let's see. Without changing the value, what will the fraction become to? 30 divided by 6. 36 divided by 6. And we have the fraction 5 over 6. And we know 5 and 6 are mutually prime, right? Yeah, so that's how do we reduce a fraction. Okay, that's the first method. If you can find the GCF for the numerator and the denominator, and you divide both top and the bottom by the GCF, you will be able to reduce the fraction. And sometimes you might not want to reduce a fraction. Reducing a fraction can be can be processed with multiple steps. The first solution, we reduce it in 1 step, right? Once we find the GCF. But actually, we don't have to do that. We can process the same procedure with more than 1 steps. If you feel more comfortable that way, that'll be also good. So for this problem, 30 over 36, we know both top and the bottom are even number, right? So they both divisible by 2. So we are going to divide both top and the bottom, by 2. And then we will have 30 divided by 2 is 15, 36 divided by 2 is 18, right? And then we look at 15 and 18. We know both of them are divisible by 3. We have the trick before. 1 and 5, 1, 5 add up to 6, right? 6 is divisible by 3, so 15 is divisible by 3. We can divide 15 by 3. Also divide the denominator 18 by 3. 18, 1, 8, add up to 9. 9 is divisible by 3, so 18 is divisible by 3. After this, we have 5 over 6. We will have the same thing. Yeah, so you don't have to complete it, reduce the fraction in one step. You can do it in more than one steps. Am I clear about that? Yeah. Whichever way you feel more comfortable. Any questions? That's how do we reduce a fraction. The second example, we're going to see how do we convert between mixed numbers and improper fractions. So first, let me explain what is improper fraction. What kind of fraction is improper? And what kind of fraction is proper? Let me give you examples. So if we have 5 over 6, in this fraction, numerator is smaller than the denominator, then that fraction is proper. Okay? If we have a fraction, the top is bigger than the bottom, like a 7 over 6, numerator is bigger than the denominator, then we say this kind of fraction is improper. That's the definition for proper and improper. Yeah. For improper fraction, we can write a fraction as a mixed number. And let me show you. Let's take a 7 over 6 as an example. 7 over 6, 7 is bigger than 6, so that is improper. Since the numerator is bigger than denominator, so the denominator could go into the numerator at least one time, right? Yeah, like this case, if we divide 7 by 6, 6 could go into 7 at least one time, but with 1 as a remainder. Do you see that? Yeah? If we divide 7 by 6, the quotient is 1, remainder is 1, right? Correct? Yeah. So this is the quotient. This is the quotient. This is a remainder. So we are able to write the improper fraction as a mixed number. Mixed number is you're gonna put a quotient. Quotient is the whole number. Put the quotient here. The whole number part. Because the 6 go into 7 one time as a whole, but it has a remainder. The remainder is 1 in this case, and we put a remainder on the top and over the original denominator. So this is 1 and 1/6. Yeah. Whole number 1, but more than whole number 1. There's another 1/6. The fraction part is 1/6. Proper fraction part is 1 over 6. Is that understandable? Is that understandable? Yeah, the other way, what if we need to convert from mixed number to improper? So what if we need to do this direction? This is how. I'm going to color them. So I'm going to color the whole number part in blue, the denominator as green, and the numerator as purple. So convert from mixed number to improper. We use the whole number part, the blue, multiplied by the denominator, green, and then add the product on top of the purple, on top of the remainder. And let's see what we have. 1 times 6 is 6. 6 added to 1, we have 7. So we end up with 7 over 6. Is that clear? Any questions? Okay, let's see the two problems here. Yeah, I'm gonna color them. This is blue, the denominator is green, the numerator is purple. Okay, the first problem is a mixed number. How do we rewrite the mixed number as its equivalent improper fraction? Improper fraction, top over bottom. The bottom would be the same with the fraction part of in the mixed number. Still 4, right? The green part. The numerator would be the whole number part, which is 2, right? Multiplied by the denominator, which is 4. So blue times green. And add the product to the numerator, the purple. Yeah, that's going to be the numerator of the improper fraction. Let's see. 2 times 4. What is 2 times 4? 8. 8 plus 3, 11. So the equivalent improper fraction of the given mixed number is 11 over 4. That's how do we convert from mixed number to its equivalent improper fraction. The other way around, number 2, let's see. How do we rewrite this improper fraction, 59 over 8, as its equivalent mixed number? Yeah, we're going to do the division, long division. We're going to divide the numerator by the denominator. We want to see, since the top is bigger than the bottom, we want to see how many times the bottom can go into the top. How many times as a whole, right? Yeah, 7, yeah, exactly, 7. 7 times 8 is 56. And we have a remainder here, right? Yeah, so 8 does not go into 59 completely. It has a remainder here. It has a remainder here. Yeah, 8 is not enough to go into like 8 times exactly. 7 times, yes, but there's a remainder 3 here. So we can see the quotient. This is the quotient. This is the remainder. Remainder. So the mixed number will be whole number part, which is 7, right? And then fraction bar. Numerator is the remainder. Denominator is the original denominator 8. 7 and 3/8. That's how do we convert from improper fraction to mixed number. Any questions? Any questions? Okay, let's see example 3. In example 3, we are going to see how do we multiply, how do we divide with the fractions. How do we multiply? How do we divide the fractions? And we will have to write a final result in the lowest form, like to reduce it. So for a second. Okay. So let's see the first example. The first example, let me copy it here. Yes, it's a 6. I want to write it here. 6 over 20 times 5 over 21 times 5 over 21. All right, we are multiplying 2 fractions. We are multiplying 2 fractions. This is very important. Not only important in intra-algebra, you will use the same idea in intermediate algebra, chapter 6. So I would recommend strongly you try to grasp the method I'm going to show you. Yeah. How do you multiply 2 fractions? My method, my rule is vertical, vertical, diagonal, diagonal, and then multiply cross. I'll explain, okay? I'll explain. So we are multiplying 2 fractions. The first fraction is 6 over 20. The second fraction is 5 over 21. Yeah, the rule to multiply 2 fractions, my rule is vertical, vertical, diagonal, diagonal, and multiply cross. The first vertical, what does that mean? The first vertical is to look at the first fraction to see if you could reduce it. Let's look at 6 over 20. Yeah, vertically, right? Top and the bottom, vertically. 6 over 20, are we able to reduce it? And how? 6 and 20, what's the GCF? 2, right? Yeah, they are both even. Yeah. So we can reduce 6 over 20 as 3 over 10, correct? Yeah, that's the first vertical. That's the first vertical. reduce the first fraction. The second vertical means you look at the second fraction to see if you can reduce the second fraction, because we are multiplying two fractions, right? For the second fraction, 5 over 21, are we able to reduce it? No. 5, 21, they are mutually prime, right? Yeah, 5 is a prime number, and 21 is 3 times 7. They have no common prime factor. They are mutually prime. Then if they are already mutually prime, I mean, if the fraction is already reduced, then you don't have to do that. You can skip the step. You can just copy the fraction. Just copy the fraction, 5 over 21. And what is diagonal? We have two diagonals. One is left top, right bottom, this direction. And let's see those two numbers. Let's see the two numbers in that direction, in that diagonal direction, 3 and 21. Do 3 and 21 have any common factor? Yes, right? Special case number 1, the GCF is the smaller number, right? 3 and 21. 3 is a factor of 21. 21 is a multiple of 3, right? And so the GCF is the smaller number. That's my special case number 1. Do you remember that? So we can divide 3 by 3. We will have a 1 here, right? Divide 3 by 3, we will have a 1. And divide 21 by 3. So this becomes 1. And divide 21 by 3, we have 7. So the left top becomes 1. Right bottom becomes 7. So far so good? And in the other direction, left bottom to right top, let's look at those two numbers to see if we can, to see what's the GCF of the two numbers. 10 and 5, again, special case number 1. GCF of 10 and 5 is 5, right? Yeah. So we can do the same thing. Divide 5 by 5, divide 10 by 5. So if we divide 5 by 5, we have 1 here. If we divide 10 by 5, we have 2 here. Right? So that is what I'm saying, vertical, vertical, diagonal, diagonal. I will show you why this method is better than the other method I'm going to show you. So be careful, after you simplify, like reduce for all the 4 directions, clean it up. Yeah, the first fraction right now is not 3 over 10 anymore, it's 1 over 2, right? Because the left top becomes 1, left bottom becomes 2. The right top becomes 1, the right bottom becomes 7. Yeah, make sure you know which number is not there anymore. It becomes to a new number. Yeah. And then multiply cross. Multiply cross. Multiply the two numerators together. So the numerator of the multiplication would be the multiplication of the numerator, 1 times 1, which is 1. And then multiply denominator by denominator, 2 times 7 is 14. So the answer is 1 over 14. And it is reduced. Yeah, let's go over the process. How do you multiply two fractions? When we multiply two fractions, we simplify before multiply. How do we simplify? We do vertical, vertical, diagonal, diagonal. Yeah, I showed you the vertical. First vertical means you reduce the first fraction, right? Second vertical, you reduce the second fraction. Diagonal, you try to reduce the two numbers on both directions. So vertical, vertical, diagonal, diagonal. All right? And then you multiply cross. Yeah, on my here I do have a second method. This is the first method. I'm going to show you why I wouldn't recommend the second method. So the second method is to multiply the two fractions directly without simplify first. So we're going to multiply cross, right? We know the top of the product is going to be the product of the top. So 6 times 5, which is 30, right? And then we multiply 20, like a denominator by denominator. 20 times 21, what is it? 420, right? Yeah, you're going to have a big number. You're going to have a big number like that. And then you have to reduce it. You have to reduce it. And we notice both top and the bottom, the last digit is 0, so we know they both divisible by 10. So we can divide by 10, divide by 10. And then when we have 3 on the top, we have 42 on the bottom. And then we notice both top and the bottom both divisible by 3. So we can divide by 3, divide by 3, and then we will have 1 over 14. Of course, you will have the same answer. But do you see the reason I say this method is better? Because the second method is kind of like a detour. You make the numerator and the denominator bigger, and then you have to reduce it after. Why don't you make the numerator and the denominator small enough, and then you multiply them cross them? Do you see what I'm talking about here? Angela, am I clear about that? Yeah. So I would recommend the first method, okay? My method, when you multiply two fractions. Yeah, so please take notes. When you multiply two fractions, you simplify before multiply. How do you simplify? You do vertical, vertical, diagonal, diagonal. And then after all the numbers are small enough, you multiply cross. Well, one thing I have to point out about my method here is you need to be clear, because you can see my notation here. I use a circle, right? 3 divided by 3, I circle it, and then I change it to 1. So you might want to use different color of a pen to remind yourself that number is not there anymore. It becomes a new number. So don't confuse yourself. If your writing is very messy, it might confuse yourself. Any question about the multiplying two fractions? Yeah, if not, let's see how do we divide a fraction by a fraction. Let's see how do we divide a fraction by a fraction. So here, my example is 8 divided by 4 over 9. Let's see this problem. Divide 8 by 4 over 9. Yeah, you might wonder, okay, the first number is a whole number, it's not a fraction. Yeah, it is a whole number, but you could write it as a fraction. You can write it as a over 1, yeah. So when you process multiplication, division, the addition or subtraction of fractions, if you see a whole number there, you can just write it as over 1, okay? Yeah, we can write 8 as a over 1. Numerator is 8, denominator is 1. And then we divide it by 4 over 9. So the first fraction is called a dividend. The first fraction is called a dividend. That's the fraction in front of the division symbol. The second fraction is called a divisor. Is the fraction right after, behind the division symbol. Okay, so how do we divide a fraction by a fraction? The rule here is keep, change, flip. Yeah, when we divide fractions, first thing we apply is keep, change, flip. Yeah, so when you read a book, do you read from the left to the right? Of course, right? When you read your phone, you go from the left to the right, yeah. When you read an expression, algebraic expression, you do the same. So when you look at 8 over 1 divided by 4 over 9, you look at 8 over 1 first, right? Yeah. So the first fraction, you're going to keep it. You're going to keep it. Keep the first fraction, 8 over 1. And then you will see the division symbol, right? You're going to change the division symbol to multiplication symbol. And then you would see the divisor, 4 over 9. And you're going to flip it. Flip a fraction means you take the reciprocal of the fraction. What is flip 4 over 9? It is interchange. Yeah, interchange the top and the bottom. You have 9 over 4. Okay? Yeah, so you keep, change, flip. I want to make sure everybody sees this process. What is keep, change, flip? Keep the first fraction, keep the dividend. Change the division symbol to multiplication. Flip the divisor. And then the problem of division of two fractions becomes a multiplication of two fractions, right? And we learned how do we multiply two fractions. We simplify before multiply. Vertical, nothing to reduce. Vertical, nothing to reduce. That happens. That's good. Then you don't have to do anything, right? And then vertical, 1 and 9, nothing to reduce. The other direction, the other vertical, look, 8 and 4. Do we have anything to reduce here? 8 and 4. Yes. Yeah. 8 and 4. What's the GCF? 4. Yeah. So that's the reason we learned GCF and LCM before, right? Yes. To prepare for this. So we divide 4 by 4. 4 will becomes 1. And then we divide 8 by 4. 8 will becomes 2. So the fraction, the dividend, the 8 over 1 becomes 2 over 1. The divisor, the 9 over 4 becomes 9 over 1. Right? Yeah, rewrite it. Yeah, after the two numbers have changed, you write them as 2 and 1. Yeah, once we simplify the two fractions, we multiply across. Yeah, this direction. Multiply across. Top times top, 2 times 9, 18. Bottom times bottom, 1 times 1 is 1. 18 over 1 is just the whole number 18, right? That's how do we process a division, the division of two fractions. Firstly, we need to keep change flip. And then we apply the rules for multiplying two fractions. Vertical, vertical, diagonal, diagonal, multiply across. Is that clear? Any questions? Any questions? Are you understanding? That's a good question. What do we change the vertical for? Yeah, let's go back to this problem earlier. I have 6 over 20, 6 over 20 times 5 over 21. Yeah, the first vertical, that's a very good question, is I look at the first fraction to see if I can reduce it. 6 over 20 is not reduced yet. Because 6 is even, 20 is even. They at least have a common factor 2. Yeah, exactly. Because 6 over 20 is not reduced. It's not in the lowest form. If we could reduce the first, like divide by 3, divide by 2, divide by 2, divide by 2, divide by 2, we have 3 over 10. Then both top and the bottom become a smaller number, right? Will be more convenient for us later to multiply across. So that the first simplify is to reduce the first fraction. The second vertical is to reduce the second fraction. Sometimes, like this case, the second fraction, 5 over 21, numerator, denominator already mutually prime, right? So it means it's already in the lowest form. Then you don't have to do anything. You just copy it. Right? And then you look at diagonal. This diagonal 5 and 10 has GCF. They have GCF 5, right? So 5 can be 1, 10 can be 2, right? The other diagonal, 3 and 21, have GCF 3. So 3 divided by 3 is 1, 21 divided by 3 is 7. So we can just simplify the two fractions before we multiply across them. Better? Okay, that's a very good question. Yeah, please feel free to ask questions if anything is not clear enough. Yeah, sure. Before that? Okay. Oh, the reduced part? The mixed number? Which part? Solution 2. Reducing a fraction, right? Okay, yes? Yeah. All right. Are we good with multiply, divide fractions. We get an idea. We're going to practice later, okay? Yeah. So that is how do we multiply and divide. Now let's see how do we add and subtract fractions. How do we add them together? How do we subtract one from the other? Yeah. So here I have the following 4 examples. I'll explain their purpose for each example because they represent different cases. So the first problem, 3/16 plus 5/16. We are adding the 2 fractions. And look at those 2 fractions. And let me know, do the 2 fractions have the same denominator? Yes or no? Yes, yes. Yeah, yes? The first fraction is 3/16. Second fraction is 5/16. We are adding them together, right? Yeah. I am asking, do the 2 fractions, the 2 fractions we're adding together, do they have the same bottom? Yes, yeah. So if they have the same bottom, that's easy. Yeah, if the 2 fractions have the same bottom, that's easy. The rule to add or subtract the 2 fractions with the same denominator is this. Keep the bottom, solve the top, reduce the result. Firstly, please write them down. Yeah, please write the rule down. We use this rule to add or subtract fractions with the same denominator. 3/16 plus 5/16. We use this rule when we add or minus fractions with the same denominator. That kind of like obvious, right? I mean, if the 2 fractions have the same denominator, all you need to do is to, when you add them together, you just keep the denominator. Denominator will be still 16. And solve the top. What is the solve the top? Solve the top. 3 plus 5. 8, yeah. And then you have to reduce it. Obviously, 8/16 is not simplified yet. Yeah. So 8 and 16, what's the GCF? 8, yeah. Special case number 1, right? So you see how convenient it is. Divided by 8, divided by 8, then we will have 1/2. Right? Yeah. It's kind of like, let's say you have a pizza. 1, 2, 1, 2. This way. Oh, it's very bad at cutting. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So here. Let's say you have a pizza. You cut a pizza into 16 slices. You have 16 people, right? Not 16 people, you have a few people. Let's say you just cut them into 16 equal slices. And then you're gonna eat 3 pieces. You're gonna eat 3 pieces, those 3 pieces. And then let's say your sister wanna eat 5 pieces. 1, 2, 3, 4, 5. Right? So together, do you see they eat half? You guys eat half of the pizza, right? Yeah, of course. 3 out of 16. That's how much you eat. 5 out of 16. That's how much your sister eat, right? So together, you guys eat 8 out of 16 pieces. So that is half of the pizza. Does that make sense? Yeah. So you might want to write it down here. The rule here: keep the bottom, solve the top, reduce the result. You apply the rule when you add or subtract fractions with the same denominator. So far, so good? So far, so good? Any questions? Any questions? Any questions? Okay, very good. Now let's see the second problem. Second problem, we are minusing. So adding and minusing, the rule would be the same. So we are going to take the difference of 5 over 6 and 1 over 2. So we are going to do 5 over 6 minus 1 over 2. 5 over 6 minus 1 over 2. Question, do the two fractions have the same denominators? No. Yeah, the two denominators are different, 6 and 2. So if two fractions have no common denominators, we cannot add or subtract directly. We have to firstly change them, rewrite them as fractions, as their equivalent fractions with the same denominator. In order to do that, we need to find the least common denominator, LCD. You might still remember these initials, right? Yeah, acronym. LCD represents least common denominator. The least common denominator of two fractions is the least common multiple of the two denominators. Yeah, you need to write that down. So when you add or subtract the fractions without the same denominator, you need to find the least common denominator for them, for the two fractions. The least common denominator of the two fractions is the least common multiple of the two denominators. Okay. What's the least common denominator of, what's the least common multiple of the two denominators, 6 and 2? Huh? LCM, yeah, you are right, it's 6. You are right, it's 6. Yeah, can you explain why it's 6? Look at it here, it's still there. It's because it is special case number 1, right? Yeah, 2 and 6. 2 is a factor of 6. 6 is a multiple of 2. So GCF is 2. LCM is 6, right? Did we practice this before? Yeah, special case number 1. So the LCM here is 6. Very good. So now we are going to rewrite both fractions as their equivalent fractions with denominator 6. So the first fraction is 5 over 6 already. We can just copy it, right? And copy the subtraction notation. And for 1 over 2, we want the denominator 2 become to 6, right? Yeah. How do we go from 2 to 6? By multiplying a factor. 3, exactly. So multiply the denominator 2 by 3, we will have the 6. But remember, we are changing the form of the fraction. We are not changing the value of the fraction. So if you multiply a number on the bottom, you have to do the same thing on the top, right? Yeah, by the multiplication property of fraction. This way, we will change the form of the fraction without changing the value of the fraction. Is that clear? So we have 5 over 6 minus, so 1 times 3 over 2 times 3, that is 3 times 6, right? That's how do we write the two fractions as their equivalent fractions with the same denominators. Is that clear? Okay, very good. So now they have the same denominators. What's the rule? The rule you just written down earlier. Keep the bottom, solve the top, reduce the result. Yeah. So we're going to keep the bottom, solve the top. What is 5 minus 3? Reduce the result. Don't forget to reduce. How do we reduce 2 over 6? Yeah, divide by 2. Yeah. Division property, right? And we have it as 1 over 3. See that? So this example, why do I have this example here? This example is to show you when you add or subtract two fractions without the same denominators, you have to find the least common denominator first. The least common denominator is the least common multiple of the two denominators. And this example, when we look for the LCM of the two denominators, that is the first special case number 1. Okay, yeah. It is special case number 1. we know that LCM is the bigger number, right? Is the multiple. So once again, feel free to ask any question. Number 3, let's see the next example. We are going to take the sum of 5 over 9 and 3 over 16. Yeah, 5 over 9. We're going to add 5 over 9 and 3 over 16 together. We are adding two fractions. Tell me, do the two fractions have the same denominator? Of course not, right? One is 9, the other is 16. So of course, we need to find the least common denominator. Yeah, the least common denominator is the least common multiple of the two denominators. Okay, you guys figure out what's the least common multiple of 9 and 16. Yeah, what's the least common multiple of 9 and 16? No, not a GCF. We're looking for LCM. It's not a GCF anyway. Yeah. So what do you do? Instead of thinking, why don't you apply the technique that we learn? Why don't you do this? Why don't you try that? Right? It won't take a few seconds. Yeah. So what do you see? 9 is 3 times 3. 16 is 2 times 2 times 2 times 2. So what do you see? I believe you can figure it out. Yeah, what do you see? Did we just go over special case number 1? Do we have a special case number 2? What is the special case number 2? How do we call the two numbers if they, Yeah, what is it? Anybody remember? Mutually prime. Do you see that? Are they mutually prime? Here, 9 is 3 times 3. 16 is 2 times 2 times 2 times 2. Do they have a common factor? Common prime factor? No, they are mutually prime. Do you see that? My second special case, mutually prime, okay? Special case number 2, mutually prime. Look at the formula on the board. Special case number 1, special case number 2, right? If the two numbers are mutually prime, GCF is 1. What's LCM though? What is LCM? What is the LCM of 4 and 7? What is 28 on the board? How do we get a 28? Yeah, you multiply. Do you guys remember that? It's in your notes. Yes or no? Do you remember that? Oh, you wasn't here. What about you guys? You guys were here. Yeah, okay. So you guys tell me, what's the LCM of 9 and 16? What is the LCM of 9 and 16? 117? 117? Really? So how do you get that number? It's not 144. Do you guys have a calculator? Yeah. 144, right? Is 144 correct? Yeah, you multiply them together. Yeah, if the two numbers are mutually prime, LCM is their product. Yeah, I have this here to be a reminder. Remember special case number 1, special case number 2. You get that? Yeah, 9 times 16. Yeah, 9 times 16 is 144. Yeah, the LCM is 144. So the least common denominator of the two numbers of the two fractions is 144. Okay, now we are going to rewrite the two fractions. Yeah, what happened? Yeah, as their equivalent fractions with the denominator 144. Let's see, how do we do that? Okay, we're gonna use the multiplication property. So let's see, from 9, how do we go from 9 to 144? Which factor is missing? 9 times which number gives you 144? Yeah, 16, yeah. So we are going to multiply both top and bottom by 16, like this, right? Yeah. So we have 144 on the bottom. What is 5 times 16? 80? 80? A calculator? Yeah, tell me. What is 16 times 5? Yeah, 80. The second fraction, go from 16 to 144. Which factor is missing? 9. So we multiply both top and bottom by 9, right? And what is 3 times 9? 27. Very good. So once you, so do you see that this number 16 is the denominator of the second fraction, and this number 9 is the denominator of the first fraction, right? Yeah. So because the least common denominator is the product of the two denominators, since they are mutually prime. Okay, now they have the same denominator. You can keep the bottom, solve the top. Tell me what you have. What is 80 plus 27? 107, right? 107 over 144. And this number is already reduced. Yeah. How do you know this number is reduced? Let me explain, okay? How do you know this number is reduced? Because both top and the bottom are so big, right? Yeah, not like a one-digit numbers. 107 over 144. Because we know 144 only have prime factors 2 and 3. Because 144 is 9 times 16, remember? So 9 times 16, right? So 9 is 3 times 3. 16 is 2 times 2 times 2 times 2. So the only prime factors for 144 is 2 and 3. However, the 107, you can try. 107 is not divisible by 2, because it's not even. It's not divisible by 3 either, because 107, 1 plus 7 is 8. 8 is not divisible by 3, right? Do you see what I'm talking about here? I see some confusing faces. Yes or no? No? So let me explain. So 144, if we prime factor it, we have 144 equals 3 times 3 times 2 times 2 times 2 times 2, right? Means 144 have two different prime factors, 2 and 3, right? However, the numerator, 107 is not divisible by 2. You can try use your calculator, because it's not even number, right? Yeah. And 107 is not divisible by 3 either. You can try use your calculator to divide 107 by 3. It doesn't work. You will have decimal. So it means that for this fraction, we cannot reduce it even further. They do not have a common prime factors. Yeah, you stay like that. Means it's already reduced. That's what I meant. How do you know this number is already reduced? That's how do you determine. Am I clear? Yeah, you got it? Yeah, what about you? A little bit? So we got this number, right? So do you understand those process? Yeah, so we got this number. Sometimes we know it's reduced. Sometimes we don't know, especially when the number is bigger, right? How do we know this fraction is already reduced? It is reduced because numerator 107, denominator 144 have no common prime factors. They are mutually prime. How do we know that? Because 144 only has two different prime factors, 2 and 3. Right? You can use the big L technique to find it out. However, 107 is not divisible by 2. 2 is not a factor of 107 because 107 is not even, right? Yeah, 107 is not divisible by 3 either because 1 plus 7 is 8. 8 is not divisible by 3, right? So it means 144 only have 2 different prime factors, but 107 don't have any of those two prime factors. So we can reduce them. Means they have no common prime factors. They are mutually prime. Better? Yes? No, you cannot use dividing to determine. You could only determine if a fraction reduced by looking at the numerator and denominator. If they are mutually prime, the fraction is reduced. If they are not mutually prime, they have common prime factors, then the fraction is not reduced. Better? I think you understand. How about you? Better? Okay. We're gonna practice, don't worry. We're gonna practice. So that is number 3. Number 3, when we add the two fractions, they have different denominators. Well, we need to find the least common denominators, right? When we find the least common denominator, is a special case number 2. You see that? Number 2 is special case number 1. Number 3 is special case number 2, right? Yeah. So let's see number 4. Let's see this problem. Let's add 5 over 6 and 2 over 9. We're adding two fractions. Do the two fractions have the same denominators? No, of course. Then in order to find the least common denominator, we need to find the least common multiple of the two denominators, right? 6 and 9. Yeah. So if you miss the class, you maybe want to borrow the notes from your classmates. We learned GCF and LCM, the first class. Okay. So look at the 6 and 9. Yeah, we are looking for LCM. Is this special case number 1? Is this special case number 1? No. The smaller number is not a factor of the bigger number, right? Yeah. Is this special case number 2? No, they are not mutually prime. Yeah, so this is not a special case number 1, not a special case number 2. It's a regular case. Yeah, if it's a regular case, how do you find the least common multiple? Do you guys remember? No, special case number 2 is to multiply. Yeah, so how do you find the least common multiple if it's not a special case? I have the process here, but I'm going to rewrite it. 3-step procedure, remember? 3-step procedure. Okay, let's see. Step 1, you're gonna prime factor both, right? So you have 6 equals 2 times 3, correct? Yeah, 9 is 3 times 3. So 9 is 3 times 3. You put them vertically, line them up vertically, right? Like that. And step 2, you red bubble common factor. Green bubble leftover factor. Do you guys remember that? Yeah. Okay. And then step 3 is you are going to multiply all the bubble factors. But when it comes to common factor, you only copy the ones, right? So in the red bubble, you have 2 3s, correct? But you only write the ones. In the green bubble, you have 2, you have 3, right? Yeah. So what is the multiplication of them? 3 times 2 times 3? 18. Awesome, it's 18. So the least common multiple is 18. The least common denominator of the two fractions is 18. Does that make sense? Am I clear about that? Why did we learn GCF and LCM the very beginning? We are using it now. Which part not clear? Tell me. Hello? Which part? Which part is not clear enough? Huh? Okay. Are you good? Okay. Feel free to let me know, okay? Yeah, feel free to let me know. Any question is a good question. All right, so we are going to write them, the two fractions, as their equivalent fractions with the same denominator 18. So now we know that's the direction we are going to go. Yeah, we're going to write both fractions as their equivalent fractions with the same denominator 18. So the blue one is going to become this blue one. The purple one is going to become this purple one. Okay, let's see. The blue one from 6 to 18. Which factor we are missing? From 6 to 18, which factor we are missing? From 6 to 18. 3, yeah, you see? Which number we multiply by 6, we get 18. 3, right? Yeah, 3. So we're going to apply the multiplication property. We're going to multiply both top and bottom by 3. Right? Yeah, multiply both top and bottom by 3. Then we would have 15 over 18. Correct? Yeah. The second fraction, the purple one. How do we go from 9 to 18 by multiplying a factor? 2. Awesome. So we multiply both top and bottom by 2. 2 times 2, 4. 9 times 2, 18, right? You see that? Yeah, that's the multiplication property that I showed you the very beginning of today, right? Finally, now they have the same denominators. What's the rule? Keep the bottom, solve the top, right? Keep the bottom, solve the top. 15 plus 4 is 19. And reduce the result. We know 19 is a prime. And 18 has no prime factor 19 because 18 is smaller. So we know 19 over 18 is reduced already. Let me go over those examples. Those are 4 examples about addition and subtraction of fractions, okay? They have different purposes. The first problem is when the two fractions have the same denominator. Yeah, when we are add or subtract. Not multiply or divide, okay? We are done with multiply and divide. Yeah. So when we add or subtract, so if they have the same denominator, simply just keep the bottom, solve the top, reduce the result. That's the first example. Yeah, if they do not have the same denominator, we will have to find their least common denominator, which is the least common multiple of the two denominators. And number 2 is the special case number 1. Yeah, when you find the least common multiple of the two numbers, it's special case number 1, right? The bigger number is a multiple of the smaller number. Do you see that? Example 3 is the LCM of the two denominators is their product because the two denominators are mutually prime. The second special case. And example 4. Not a special case number 1, not a special case number 2. When you look for the least common multiple of the two denominators, you have to apply the 3-step procedure to find the LCD. Okay, so that's how do we operate fractions.